Personal finance practice problem using OneNote. Present value of an annuity calculation using monthly periods as opposed to yearly periods. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab in the 1222 Present Value Annuity Monthly Periods tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our practice problems will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculations on down below. We're looking at a present value of an annuity, this time with monthly periods as opposed to yearly periods. Remember that when we do this transaction or when we do these types of transactions, there are different methods that we can use. More often, some of them being used in practice, some of them being used in a school setting. In particular, the school setting items, and more in particular, the tables, are often severely limited when you start to go to things like compounding monthly due to the number of periods that will often be involved and the uneven or smaller numbers with regards to the monthly rates. So as we go through the different calculations, including Excel function, formulas, and the use of tables, note the pros and cons of the different formats that will be used, and note that in practice, the compounding or more compounding as would possibly be applicable or appropriate for certain problems is not really a problem when you're talking about normal tools that you have available to you in this day and age, as opposed to if you're restricted in such as a school setting when they try to take those tools away and give you something like tables. Okay, so how much would you have to invest to be able to take out each month $1,500 for 3 years? And we're going to be taking it out on a monthly basis. So that means that we're talking about 36 months. We're going to be taking out, or would like to take out, $1,500 monthly for 3 years, which means period-wise, that would be 36 periods. The rate is going to be 12%. That's a yearly rate. And notice that unless given or stated otherwise, people will be giving you a yearly rate. That's just a convention. And that convention makes sense because the yearly rate will typically be between 0 and 100, whereas a monthly rate, as you can see here, even with a fairly high yearly rate of 12%, if I divide it by 12, it's 1, so it would be 1%. Anything less than 12, you have a rate that's going to be less than 1, which is more difficult to communicate, and also it's more difficult. You can't use the tables when you have an uneven or a rate that's less than 1. So keep those things in mind. We're looking at a present value of annuity calculation because we're thinking about how much we would need at the start as of now, as of this present value time period, a lump sum, so that we could then take out $1,500 for 36 periods or 3 years in monthly terms, 36 months at the rate of 12%. And so that means that we're gonna take that present value of that series of annuities in order to do so. So we're gonna go down. We're gonna do our present value calculation. In other words, how much money would we need at this point in time in order to make that possible? So we'll be down here. Let's first think about it with regards to an Excel function, most likely done in practice, most common tool in practice. We have equals the negative. The negative's to flip the sign. You could put it in front of the payment. I like putting it in front of the PV or the function entirely. We then have the rate. The rate's going to be not the 12% because that's a yearly rate. We got to make it a monthly rate so it matches the periods, which are monthly periods. We're doing that here by taking that cell and dividing it by 12. Note that results in a very small rate, but 1% in this case, which isn't too bad. But if it was a small rate, like 5% divided by 12 would be an ugly number. It's not a problem if you're formatting it in this format in Excel, because Excel will then take the actual number, and that's how you can kind of put this together and take the monthly rate. And so then we're going to say, comma, the number of periods is not 3 years, but rather 36, which you could, if you have your data set, take 3 times 12, or in this case, we're simply referring to that 36 cell up top. And then we have, comma, the payment. The payment's going to be that $1,500, which we're assuming is on a monthly basis. Payment generally given for whatever period that's going to be going for, in this case, monthly payments. So that would then give us the present value of $45,161.26, meaning that if I had this lump sum at the beginning, we should be able to take out the 1,500 every month for 3 years, which would result in 36 months or periods at the rate of 12% annual, but compounding monthly, or in other words, the monthly rate being 1%. And note, obviously, if you were to take out that much money, 1,500 times 36, it would be 54,000. But we're saying we're only needing the 45,161 because we're going to be earning a return on the amount that's still in the investment. Let's do that again. This time, let's run it with the tables. This is the other way, which I would think would be very common in practice, less so in an Excel or like a school type of setting, because once again, you don't normally have the tool of Excel, but this will give you more information. Note that obviously it's a lot longer of a table whenever we're talking about monthly periods as opposed to yearly periods, which seems kind of overwhelming, but if you get used to doing these in Excel, they're very easy to do, and they still give you a good amount of information. We do this problem in Excel, so go ahead and practice that if you so choose, or just try to fire this up or plug this into Excel. Okay, so we're gonna start with the 45,000 here to prove this. So now we've got our 45,000, and we're gonna basically work backwards, taking out the payments. And if we were to do so for 36 periods and do this properly, we would end with an end result of 0. So the calculation would be something like this. We would take the 45,000 times the rate, which was 12% a year, so 45,161 about times 0.12, which is the yearly rate, would give us the yearly interest, or whatever the increase was, depending on the type of investment, divided by 12, would give us the 452, which can also be calculated as the 12%, 0.12, divided by 12, the monthly percent, or 1%, times the 45,161, gives us that 452 again. The amount of the payment, 1,500, obviously the payment being higher than the earnings that we're going to be receiving, therefore the investment will go down, resulting in the earnings over time to be decreasing. So we've got the 45,161 plus the 452 minus the 1,500. There's the 44,113. Taking that times the 0.12 yearly rate, that would be the yearly amount divided by 12. That would give us our increase for year 2. We won't do this 36 times, by the way. So I know if you're looking forward to doing this 36 times, just get as much enjoyment as you can out of the first couple here, because that's all we're going to be able to do. So we're going to take that 441, which you can also calculate as 44,113. Sorry, hold on a second. You can also calculate times 0.12 divided by 12 to give you the monthly rate. Then multiply it times the 44,113. And that'll also give you the 114. We're going to take out another 1,500. So we started with 44,113, then we earned 441 on it, minus the 1,500 means we have left the 4354. We're going to do it again, taking that times the 0.12. That would be the yearly amount divided by 12. Monthly earnings would be 431, which can also be calculated by taking the 12%, 0.12, divided by 12 to get the 1% monthly rate, times the 43,054 to give us that same amount. We can then say that we're going to take out the 1,500, so 43,054 plus the 431 minus the 1,500 gives us then the 41,985. Let's do it again. One more time, last time. This is going to be this one times 0.12. That would be the yearly amount divided by 12. Would give us the monthly amount of earnings, which would be the 420, which can also be calculated by taking the yearly rate, 0.12, dividing it by 12, 1% per month, times the 41,985 would give us that 420 again. Taking then the 1,500 out, we then have the 41,985 plus the 420 minus the 1,500 gives us the 40,904 about. So if we did that then 36 periods times down here, which is easy to do in Excel, difficult to do here with simply a calculator, we get to the end result finally of the 0 down here, and we get to see what's actually happening with regards to the earnings that are taking place over time, which can give us more information when we're doing this in practice in the decision-making process than simply the number we get from the function. We can also do this with a formula. So this is something you might more often be doing in a school setting. You probably wouldn't, do the formula too often in practice because you'd probably be using some other tool. And we could plug this simply into the formula. So we could say P, present value of the annuity, is the payment 1,500 times 1 minus 1 over 1 plus R, which is going to be the rate, not 12%, because that's the yearly rate. It would be 12% divided by 12, or 1%, the monthly rate, to the power of n, number of periods, not years, not 3, but 3 times 12, or monthly periods of 36, divided by R, which, again, is not 12, but 12 divided by 12 to get the monthly rate of the 1%, making sure that whatever R is, it needs to match the same period, the rate per period, as the period is, meaning n, the period that the period is in, months, years, semi-years, and so on. Once we have that, we're going to plug that into our table down here, and we'll make this into like a table type of format, as we've seen in the past, pointing out those differences. We got this long table that we'll put together, since this is somewhat of a complex formula in like a tax return type format. The payment, the 1,500. You got the numerator, this whole thing up top. It's going to start with 1, and then we're going to take this whole thing, which is 1 over the denominator, so 1 again. And then we've got the 1 plus R to the n, which is this denominator component. So we've got the 1 plus the rate, which is 1%. Here's one of the differences. 12 divided by 12 is 1%, the monthly rate. That will give us the subtotal of 101 to the number of periods, not 3, but 36, 3 times 12 periods. And that would give us that 1.43077. Let's do it with a calculator, noting that you need a calculator that can take something to the power of 36. So for me, I'm going to go back to the scientific calculator. We're going to do something scientific like here. We've got 1 plus the 0.01 is 1.01, or 101% to the power of, to the xy, caret 36. And that's going to give us that 1.43077, so on. Then I'm going to go back to the normal calculator, back to the normal, non-scientific, but still very analytical, normal calculator. And then that's going to give us then this divided by the denominator. So that's in this column, 1 divided by that whole thing. Let's do that. 1 divided by 1.43077 gives us about 0.698925 about. And then we've got the numerator, which is that 1 minus that whole thing, which is in this column, 1 minus that entire thing. So I won't do the calculation. That gives us the 0.30175. And then we finally have the denominator, which is the rate again right there. The rate, which is not 12, but 12 divided by 12 and 1. So we divide that out. So we can do the numerator divided by the denominator. 0.301075 divided by 0.01 is the 30.1075 about. And then finally, we can take the payment times that whole thing, which is the 1,500 times that, 1,500. And we get then approximately the 45,161. This number is more accurate than our number because Excel will calculate the actual number even when rounding is involved. Let's do it again with the tables now. Remember that the tables are the most restrictive things, and when you're in a school setting, that's why school problems, even when you look at a problem, you say, hey, look, in practice, oftentimes this type of problem would be in the format of monthly periods. The school is putting it in the format of yearly periods. Why are they doing that? Because they're forcing you to use the tables, which severely limits their problem. So notice that you don't have those limitations in practice when you have Excel, because it becomes quite easy to deal with uneven or messy numbers that way if you practice it a little bit. So that's why you're going to get these even numbers. So if I'm going to use monthly periods and I have to use a table, then I got to use something like 12% or above. I got to use 12%, 24%, 36, so that when I divide it by 12 to get the monthly percent, I have an even percent and one which is over 1. I can't use anything less than 1 because the percents down here are between 1 and 30%, and they're all even. So that's going to be a limitation. My periods only go up to 50 periods, and they start to kind of space out substantially down here at the bottom. So then I'm very limited to the number of years I can have. I can't do like a home loan, 30-year loan, which would be 30 times 12, 360 periods very easily. I can't do it at all with the tables. In practice, I can do that very easily with Excel, and I can do a running balance table for 360 periods if I want to. Not a problem. So don't feel like once you do a lot of book problems that those limitations are real limitations in real life when you actually have tools like the computer, to help you. So if we use the tables, we're going to say, okay, we got then this 1,500. We got 3 years, which is 36 periods. 12%, the yearly percent divided by 12 is 1%. So we're looking 1% and 36 periods. So we got the 1%. And the 36 periods, which is going to be 30.108. 30.108 times the 1,500 is going to give us about the 45,162. Let's do it. 1,500 times 30.108 is going to give us about or exactly the 45,162, which is slightly different than what we got up top here, because this is the more exact number due to the fact that this is the actual number from the table. If they were to take it out more than 4 digits, which is 30.107505 and so on, and they rounded it to 4 digits, which means there's going to be a rounding difference. They rounded it to 3 digits, which means there's going to be a rounding difference in any case. So that whatever tables that you're using, there will typically be some kind of rounding difference in them due to the rounding of the tables. In this case, it looks like to 3 digits.